Let's also take a look at ratios and proportions. So a ratio is just a comparison of two quantities, or it's the relative size of those two quantities expressed as a quotient of one divided by the other. So ratios are often written as this A colon B or A divided by B. Ratio is a type of fraction. So where might we see ratios? Well, in a recipe, the ratio of eggs to flour may be 4:3. So if you are using 4 eggs, then it would be 3 cups of flour. But if you were to triple that, then you would use 12 eggs, but you would need 9 cups of flour. That ratio has to stay the same. Looking at medications, we often are looking at concentrations. So the ratio of amoxicillin to, I don't know how to say that, versus Augmentin can vary from 16:1 to 2:1. Or a liquid steroid, I'm terrible with these drug names. Basically prednisone, sodium phosphate, it's listed as 25 milligrams per 5 milliliters. So that's giving you the concentration, how many milligrams of the drug there are per 5 milliliters. We also, when you're looking at, say, something like blood alcohol content, that's also a ratio, and it's how many, I believe, I don't remember the units, but it's how many grams of alcohol per a certain deciliters of your, or per liter of blood. So we have these ratios to help us understand, if you were to break it down into a little piece, how much of one is there compared to the other. Ratios are very helpful for us when dealing with rates. Rates are ratios of two quantities with different units. We see these all the time: mile per hour, milligrams of medicine per kilogram. A unit rate is going to be a rate that has a denominator of 1. These are really useful when you're trying to make comparisons. Going to the store and looking at the different size jars of things like spaghetti sauce, Prego, peanut butter, all the things that come in lots of different sizes. Well, how would you figure out which is the better deal? A 24-ounce jar for $1.98 or a 67-ounce jar for $4.97. That's not an easy comparison to do without a calculation. So we can do what's called a unit rate by taking the price and dividing by the size. And here, when you divide $1.98, so 1.98, and divide by 24, you're looking at 0.0825 per ounce. This helps us then compare the larger jar, that's $4.97, but you get 67 ounces. You would do 4.97 divided by 67, and you get 0.074 per ounce. I'm sorry that got all spread out. Let's write that a little better. Often you will find that the larger container is a little bit cheaper, but not always. So it's always good to check before you buy the larger container, because it may actually be cheaper to buy a couple of the smaller ones for a larger, if you have a need for a larger jar. But here, the unit price can be used to figure out which one's the better deal, and in this case, it is the 67 ounces. However, only if you actually need 67 ounces or can use that in the amount of time before it goes bad. If you ever go to the big warehouse stores like Sam's Club, things like paper towels, toilet paper, sure, you can buy in that huge giant bag because they're not going to go bad for a while. But if you're going to buy 17 pounds of potatoes, you need to make sure you're going to eat the 17 pounds before they go bad. So sometimes things are a good deal when you're buying in bulk, but sometimes it's not if you can't use it all. Another ratio application is actually scale factor. We do this when we're looking at scale models, so a small model of something, or if, you are back in the 90s and you have to read a map, every once in a while we have to look at a map. So we can use scale factors to help us compare things in a geometric interpretation. So here we've got a Batman Hot Toys movie masterpiece. It's a 1/6 scale collectible vehicle of the Batmobile. So this is going to be 1/6 of the size of the actual Batmobile. It's actually going to be pretty big. So if the dimensions of this scale collectible are 39 inches long, 16 inches wide, and 9 inches tall, how big was the real Batmobile? Best way to do a question like this is to set up a proportion and solve. But just a quick algebra review. It might have been a minute since you've done some proportions. So let's just look at this other example. It has nothing to do with the actual problem. We're going to solve this proportion 5/4 equals x over 8. To do this, we cross multiply. We multiply the 8 times the 5 and get 40. We multiply the 4 times the x and we get x, or 4x. Now we can solve by dividing both sides by 4, and we get x equals 10. And this is actually where we're going to stop this lesson. We will solve the Batmobile problem, don't worry, but that's going to be in our collaborative exercises for this week. We'll do that as well as the group activities. If you have printed out the rest of these notes, you'll see that there are some group activities here. And we'll be doing all of those for our collaborative activities for the week.